This is problem 6-18 for session 3 on the time value of money. This is a typical example of non-annually compounded interest rate. In this case, it's a daily compounding. And as we said, normally the interest rate, as if the problem doesn't mention whether it's the periodic interest rate, the interest rate normally is quoted in annual terms, and that's called annual percentage rate. So if you read the setup, it says an investment will pay you $35,000 in 10 years if the appropriate discount rate is 6.2% compounded daily. So this means 6.2% is the APR, is the annual percentage rate. But this compounding period is daily. So that means we need to get the daily interest rate to work for this problem. And what is the present value? So if we write down the formula, we know that normally the present value formula is present value equals future value, right, times 1 plus interest rate and raised to the power of negative t. Or you can also write this as future value and then divided by 1 plus interest rate and raised to the power of positive t. So R is the interest rate and T is the compounding period. Because here we have the daily compounding, so T should be the number of days and R should be the daily interest rate, and future value, that's the based on this top here, that should be $35,000, right? So then the rest of the job is to convert the information we're provided into the daily numbers. And R, as we said, is 6.2%. This is the APR, and then we should divide that by the number of days, right, within a year, which is 625 or 365. So I don't want to calculate it for a specific number because this will not, I don't want to round for these intermediate results. If you look at the setup, it says first use 365 days a year, do not round intermediate calculations, and finally round your answer to 2 decimal places. So let me just keep this way. And T, as we said, in this case, it should be 10 number of years and then times 365 number of days for a year. So this will give me 3,650 days. So this is days. And FV is 35,000. So then this will equal to 35,000 divided by 1 plus 6.2% and divided by 365 and then raised to the power of 3,650. So the rest of the job, you can have multiple means to get the final answer. First, you can just use your normal calculator, but remember, sometimes you may forget to put a parentheses around this, and that's very important. And 2, you can use Excel to do that. So let me open. So this equals, going back to my expression, so that's going to be 35,000 divided by parentheses open parenthesis 1 plus 6.2%, and then divided by 365, and close that, and raise to the power of 3,650. Just double check to see yes. So that's the second way to get the answer. And the third way is simply to use the PV function in Excel equals PV and open. Open should be the interest rate, the daily interest rate, the first argument is the interest rate, right? 6.2% divided by 365. And then the NPER is the number of compounding periods. In this case, is the number of days before you receive the payment. So 3,650. And payment, that's the annuity payment. In this case, we only have one future value payment. So this would be 0. And future value is 35,000, right? The type, we don't have to care about this. This just means whether it's the beginning of the year or end of the year convention. Normally, it's the end of the year, as we assume in this case. So if you just type $35,000, you'll see that we're going to get a negative number, but you can see the absolute value based on this PV function in Excel will be the same as what we directly calculated using the arithmetic in Excel. But if you want to get a positive value for this, you need to put a negative value for the future value. So that's basically the rule for Excel or your financial calculator. So the rule is that the current cash flow and the future cash flow, they will have opposite signs. But you can see that it's either way you will get the same answer. So now let's check whether we got the right answer. 18,829.05. And I have followed the rounding requirement to round to 2 decimal places, basically. So it's 18,829.05. 18,829.05. And let me check my work. All right.